Hello everyone and welcome to a new Sega Mega Drive game dev tutorial. In today's lesson I'm going to cover a much requested topic, and that is how to do tile scrolling. As I'm sure everyone watching knows, the Mega Drive only has two background layers for parallax scrolling, but by using tile scrolling we can add a lot more depth to the backgrounds. And by skillful use of this technique we can even make it seem that the Mega Drive is displaying 3, 4 or 5 layers. One of my favourite Sega Lord X videos is his glorious Wonder of Parallax Scrolling episode. I'll leave a link to that in the video description in case you haven't watched it, but today I'm going to teach you how to create your own wonders on the Mega Drive. Okay, so this is a starting point for today's tutorial. You can see that I've created a special background just so that we can see where, because we're going to do horizontal tile scrolling today. So each tile is 8 pixels tall, and I've created this, this background just so we can clearly see where one row ends and another begins. And you can ignore the green rows at the very top and bottom. That's just part of the screen that you normally don't see displayed on the TV. Our starting code is very simple. I think it's actually the first lesson I covered, how to display a background. It's just a very simple background display, nothing special here. Although of course for the Patreon supporters I will provide the full code for this lesson over on the Patreon. Okay, so our first step today is going to be enable the tile scrolling mode rather than the regular plane scrolling mode. And to do that we need to use the SGDK function, the VDP_set scrolling mode. You can see on the left hand side the helpful description of the parameters this function takes, so I'm going to go through it with you now. What we basically need to tell the system is what kind of scrolling we want horizontally and vertically. For the first parameter we need to enter what kind of horizontal scrolling we want, and for this lesson we're going to choose the tile scrolling. Although of course you can probably see there's also the option to do line scrolling too, and the process for doing that is very similar to the tile scrolling. For today's lesson though, just choose hscroll_tile because we're going to scroll by tile, so remember each tile is 8 pixels tall. And for the vertical scrolling we're just going to choose the plane scrolling. I'm actually not sure if you can combine a vertical and the horizontal tile scrolling at the same time. That might not work, I don't think it does, but anyway today for the vertical we're going to use the plane scrolling. Okay, so within main we've already told the SGDK what kind of scrolling we want to use, we've set that up, but now of course because scrolling needs to be updated every single frame we're going to need to use another function within our while loop, and that function is VDP_set horizontal scroll tile. This function takes 5 parameters, so let's go through them now. First of all we need to tell the system on which background layer we want to apply this the horizontal tile scrolling to, what layer is going to affect, and we're using the background layer BGB_B here. The next parameter is asking us on which line we want to begin the tile scrolling. Now we want to start from the very top. In lots of circumstances you'd have clouds or something at the very top, so let's set this to 0. The next one might seem a little bit tricky, but here we're simply going to put the name of the array we're going to be using. Now if you don't know what an array is, don't worry, I'll explain it in a second. It's basically the values that each line is going to scroll by. You can give this whatever name you wish, but I'm going to call mine tile scroll array. It's going to give us a little error here, but don't worry, we're eventually going to define this array and then it'll be fine. The next parameter wants to know how many lines, I mean individual tile lines, we want to scroll. Now the height vertical resolution is 224 pixels. If you divide that by 8 you get 28. So it starts at 0, then it ends at 27, so 28 in total, so we're going to write 28 here. And for the final parameter it's asking for the transfer method. Let's just follow the recommendation of SGDK and let's choose DMA_Q. Okay, with that complete, now let's turn our attention back to that array I mentioned. When we did the parallax scrolling lesson a couple of years back, we basically just needed one single variable value to represent how far the screen had scrolled by in the horizontal direction, and of course another variable for the vertical direction too. However, because we're using tile scrolling here, we have 28 lines, so we need to hold 28 different values for each single line. And the way you define an array is similar to how you define a variable, so we use a data type first. In this case we're using a signed 16-bit integer S16, which would be big enough. You have negative and positive numbers enough to use today, and then we put the name of it, and then in the brackets, these square brackets at the end, we put how many values are in the array, 28 in this case. Okay, now let's go ahead and actually fill in those values. So remember we need 28 of these, so we need to do put the data type, the name of the array, in brackets how big the array is, then an equal sign, and then curly brackets, and that's where we're going to put our values inside, separated by normal commas. And then at the very end, at the end of the last curly bracket, don't forget to put a semicolon. So to begin with, let's just set all the values to 0, so it means that each horizontal line will start off at 0 scrolling. I've separated these into rows of 5 just to make it more readable, and of course if we do that 6 times, eventually we're going to get to 30, and that's going to say, hey, there's an error. You only said you had 28 values in this array. So we're going to have to delete 2 of them, so it goes to 28. And doing that will make the error message disappear. Okay, so we've basically got all we need in place to implement the very basic tile scrolling. We've got the array here, given the value of each individual row. And we've already set it up in main to tell SGDK that we're going to use tile scrolling, not plain scrolling for the horizontal scrolling. And in the while loop, we've also got the function that updates the scrolling every single frame. And that function, of course, takes the information from the array we just did. And if we save and compile, this is the result we get. Now at the moment, there's no change because of course we set all the values to 0. But if we were to change some of these values, for example, to a positive or negative number, it will shift each row either right or left. So if I were to change the first value to 10, for example, it should shift the very top row, which I'll mark as 0 on the graphic, 10 pixels to the right. And if I do -5 for the next one, it should shift the one below it just 5 pixels to the left. I'll just make a couple more changes now and then we save and compile and see how it looks now. Okay, so you can see that the ones I've altered, rows 0, 1 and 5 have changed. So 0's gone 10 pixels to the right and 1's gone 5 pixels to the left because it's a negative number, and 5 I think I made it 100 to the right. And for the rest of the numbers, please note that in the original background graphic I made it so that the numbers appear not completely at the left hand side but a bit more to the right, just so I could see them more clearly, especially once we go into negative numbers. So that's great, we're making progress, but that's just a static change. So what we want to do of course is to change the scrolling value of each row, each frame, because that of course is what's going to give us that beautiful parallax scrolling movement that we're aiming for. This can get a little bit tricky, but don't worry, I'll take you through it step by step as we change each row dynamically, each frame. First of all, we're going to want to copy the name of the array and paste it within the while loop. With arrays, it's actually very easy to change any single value within an array. All we have to do is put the name of the array, and in the square brackets we have to put the value we want to change. So 0 will be the first value in the array, for example. If I then do +=1 like here, what is it going to do? Every single frame is going to add 1 to the very first value in the array. That is this one here. So remember we made that 10. So on the second frame it's going to be 11, then 12, then 13 and so on. And so it should be moving to the right. And now let's save and compile and see if it works. Okay, great. So you can see our first row labeled 0 here, which is the 0 value index of the array, is now moving to the right constantly by 1 pixel per frame. Of course, I can also copy and paste that code and also use it to change other rows too. So in the square bracket, instead of putting 0, I can put 20, row 20, and then I can do -10 instead of +1. So they should start moving 10 to the left each frame now. And success again. So you can see now that row 20 is moving to the left at a rate of 10 frames for 10 pixels for every frame, which is a bit faster than I expected. So I don't think my old eyes can keep up with this. So let's change it to a bit of a slower number, but at least the codes are working as we expect it to. Okay, so that's easier to follow now. It's a bit more comfortable on the eyes. Well, that's fine, and 1 pixel per frame isn't too fast, but what if we want to make it slower than that, for example with clouds or any kind of other very slow moving background elements? So we want to use a decimal number, for example, 0.5 or even 0.1, but unfortunately the function there only takes integers, only takes whole numbers. It doesn't take decimal numbers, so we're going to have to do a bit of coding here to make it work. My solution to this is to create a second array, same as the first, but instead of using the S16 data type, whole numbers, we're going to use fix16, which will be decimal numbers. If you recall, for player movement, I recommend using fix32, a 32-bit number, because we really need that for player movement. You need that higher of a number, but for our purposes here, for the background scrolling, fix16 will be fine. And of course, because this is a different array, we need to give it different names. So just to make clear, I just change the name a bit to as F16 so we don't get them mixed up. And of course, also don't forget to change the data type to fix16 too. And of course, being an array of fix16 numbers, it can't take these whole numbers. So we need to change these to, we're going to use the capital letter fix16 brackets, and then we put a number in each one. So let me just make the changes here. I don't think we've used fix16 before, but we've used fix32, so the process here is basically the same. And again, as I copy and paste, I'm going to create an array of 30 values and it's going to complain, so just delete the last 2 and it'll be fine. Since we've now already begun to dynamically change the scroll values in each frame, let's just change all these back to 0 because we don't need to start at these kind of strange numbers. So let's go back to our original array with the whole numbers and set all these to 0. Okay, back in our while loop, we're going to now start to change some of the rows by decimal points, not by whole numbers. So let's do that now. And what we're going to do is we're just going to take our new fixed 16 array and we're going to add some fixed 16 numbers to it. Let's do this for row number 1. So this will be the second row, because remember we start counting from 0. So we're going to change that by 0.5 each frame. Of course, just changing our fixed 16 array is not going to make any difference for the actual scrolling at the moment, because of course the function we're using to manage the the tile scrolling, it only takes the integer value, so it only uses our original array. So what we need to do is we need to take the value in the fixed 16 array, we need to convert it to an integer, then we need to essentially copy that into the same position in our integer array, into an original array. Right now I'm using SGDK version 2.11. One of the changes it made is it changed, we used to use fixed 32 to int or fixed 16 to int to change fixed 32 or fixed 16 to an integer, but they've changed the syntax of that now, so you can't use that anymore. So let me use the new syntax to do that. Okay, so with our fixed 16 array updated and with the result of that then transferred over to our original integer array, and which of course then gets based into the function, let's save, compile and see what the result is. Okay, great. So you can see that 1 is moving at roughly half the rate of 0, which is moving at 1. So 0 is moving at, I think, 1 per frame, and then our new one, our row number 1 is moving at 0.5 per frame. So at this point you could say we're pretty much done. We could, from here, we could just simply copy and paste the code we just created, and we could do the same for every single row in our array. So we have 28 of these, change each one by a different speed and we'll be done. But if you can imagine, copy and pasting so much time and having all the same code be done over and over again, it doesn't look very pretty, and thankfully there's a much less time consuming and much neater way of doing this. So instead of doing this super clumsy copy and paste method, instead we're going to use something called for loops. Now I can't recall if I've taught for loops before in this tutorials, but don't worry, again, as with everything, I go through it step by step, so I think it'd be easy for everyone to understand. Actually, before we go ahead and start using for loops, first of all I want to create one final array. This is also going to be an array of fixed 16 decimal numbers, and in it we're going to store the speed at which each line moves. You can see here that I've just copied and pasted our previous fixed 16 array just to save time, but of course we're going to have to change it and give it a new name now. Something like speed of scrolling for each line, or call it whatever you like. With the array renamed, we can now start entering the speed values for each line, so I'm going to do that here. Now instead of directly adding the speed as entering it manually as before, now I'm going to instead take that value from the array we just created. If we now save and compile, the result should be the same as we had before. So you can see that the lines are still moving as they should, so it's been a success. Okay, now let's move on to the for loops. For loops are very useful when you find yourself repeating the same step again and again on the same set of data, like the array in this case. So what we're doing while setting up this array is just making every single value in it equal to 0. Since we're only doing tile scrolling in this case and we only have 28 values, it's not too bad, but if you imagine you were doing line scrolling and you'd had 224 values, it'll be very awkward and messy and time consuming and mistake prone to write 224 zeros. Just above the array you can see that I've just written the basic syntax for a for loop. You can see that we have the word for, then we have open brackets, and within those brackets we have 3 pieces of information separated by 2 semicolons, and then finally we have the curly brackets. The syntax of a for loop is easy to understand once you know how. So first of all, you have to declare a variable. So in this case, I'm using U8 because that can be up to 255, and we only have 28 values within our array. So that will be fine. If you need a bigger one, then you can use U16 instead. Often you can call it whatever you like, this variable. I'm going to use the letter I, and in C language for for loops, you see that most people tend to use I. It's a bit of a convention, but you can actually call it whatever you like. Now it's important to note that this variable you just created, this I variable, only exists within the for loop. So if we try and do something to it outside of the curly brackets, you'll see that the compiler won't recognize this. It will say, what the hell is this? It only really exists within the curly brackets. Okay, so after we define that variable, we have a semicolon, then we have this second piece of information. Now this just means how many times you want to go over the loop. So how many times you want to perform a certain action. Now since we have 28 values within our array, we're going to set this to less than 28. So remember, we start counting from 0, so 0 to 27 inclusive will be 28 in total. And after the second semicolon, the third piece of information, we're just going to write I++, which just means we're going to hit every single piece of data in the array. We're going to go through from 0 to 27 one by one. So what we want to do here is we want to go through this array and we want to make every single value equal to 0. So we're going to take up the name of our array. This is the whole numbers, the scroll position. And we're going to, in the square brackets, we're going to put the I in there and we're going to make it equal to 0. So remember, the for loop is going to go through from 0 to 27. So that I is going to be replaced each cycle with 0, then 1, then 2, then 3. And it's going to go through the whole array one by one, and it's going to assign 0 to each value in the array. And once it gets to 28, it's going to stop because remember we told it to stop once it gets to 28. And now, because we're setting all the values to 0 within our for loop, we can simply get rid of the curly brackets here. So we still need to declare the array. So we still need to create the array before we go through the for loop. But so long as we create the array first, then we can go through the for loop and we can assign everything that way. So rather than having all those lines, we simply have one line of code that does the same job now. Let's just comment out the actual movement in the lines for now, just so we can save and compile and make sure that we did it successfully, that everything's working okay. Okay, so it looks like everything's at 0 as it should be, but let's change it to 100 now, and all the lines should shifted to the right by 100 pixels. So let's see if this works. Okay, great. So it seems that the for loop is working fine. Everything was shifted to the right, so that's looking good. And just to make sure, if I change it to 200, we'll get this result. Okay, now let's just change this back to 0, and you'll probably notice that we can do the same thing within the same for loop since we've got it set up already for the fig16 array too. The fig16 version of the scrolling coordinates. So as the value of I is iterated from 0 to 27, it's going to change both arrays. So in the first array, it's going to put 0, and in the second array, it's going to put fig16 0. And again, just like last time, it means that we're not going to need to manually write out assign every part of the array to fig16 0, just like with the other array. And we're also getting an error message here, and that's because we've defined the array below where the for loop is. So we have to make sure we define the array first before we do the for loop. Okay, that's great. So just as before, we haven't had to write out all these zeros again and again in this kind of clumsy way. Instead, now we have this quite elegant for loop that achieves the same result for us. Now, when it comes to our third and final array, where we record the speed at which each line moves, obviously we can't do the same again because each of the values here needs to be different, because some lines maybe represent clouds, some represent mountains, some maybe the forest, and so they're going to be moving at different rates, so they're not all going to be 0, so we can't put them into this for loop. However, what we can use a for loop for is the process of adding the speed to the fig16 array and then having that convert from fig16 to the whole numbers so it can go into the function. If you recall, a few minutes back I said I didn't want to have to write these two lines again and again for every single member of the array. I didn't want to have to repeat this 28 times. It'll be not very nice code. So instead of doing that, let's write a nice concise little for loop. And remember with the previous for loop where I said that the I variable is just something we use to go through the indexes of the array and it exists within that for loop. It means that we can also call this variable I, because again this one only exists within its own for loop, so they're not going to clash or anything. Okay, next let's copy those 2 lines of code which add the speed to the fix16 array and then converts that fix16 array value and transfers it to our whole numbers array. And then instead of having the hard numbers, we're going to replace those numbers in the square brackets with I, of course, and it's going to iterate through from 0 to 27. And of course, while the other for loop is happening within main, so it only happens once, it's just to set up the arrays. This one is happening in the while loop, so it's happening every single frame. So we get the speed added, we get the conversion to whole numbers, and then in the end, we'll put that into our VDP scroll function, which of course exists outside of the loop. And if we save and compile, we should get this result. So everything's working fine. It's been set up correctly, the 2 arrays, and the actual array movement, the scrolling part seems to be working correctly too. So let's just clean this up quickly and delete those commented out lines. And back at the top of the file, I just want to give you one last tip. It might be useful to have a regular variable which records the speeds of different elements, because for example you might have clouds. These clouds might take up several lines and they're all going to be the same speed, or you might have mountains which take up several lines and they'll move at the same speed too. So you can, instead of writing them individually within the speed array, you can create these variables. So you can assign them a certain value, and then we can simply put that variable name into the array instead. And that makes it easier if you decide to change those speeds later on. It means you only have to change the value once instead of having to go into the array and change them manually maybe 3, 4, 5 times. You can see that I'm replacing positions 0, 1 and 2 in our array with the cloud speed. So if you check here, if we save and compile, you can see that 0, 1 and 2 are always all moving at the same speed, the same very slow 0.1 per frame speed. Although if I did want to do clouds, I probably want them to move in the other direction, the opposite direction, so I should probably make that a minus number. And as I slowly scroll through the completed code here, you can see that we don't actually have that much code written. We did have a lot at first, but then we managed to clean it up quite a bit with the for loop, so now it's looking quite efficient, and I'm really looking forward to what kind of amazing parallax effects everyone's going to come up with. You can see here an example I did a couple of years ago, just replicating the Shinobi 3 level, and I don't know what's going on with Shinobi. It wasn't like this in the original. I think I did the original one back on SGDK 1.7 or something, and obviously upgrading it to 2.11's created some problems. I'm not sure why Shinobi's jumping like that. In the original version he was able to jump fine, I had that worked out, but it's going a bit crazy now. But you can see the nice effects that you can achieve with this tile scrolling. And if you use both background layers in conjunction with each other and change the priority, flip the priority every now and again, and even include some background sprites, you can achieve some multiple layers of parallax. And for those of you who fancy a challenge, maybe try recreating this great scene from Thunder Force 4 using the line scrolling functions, the whole setup of which should be similar to what we've done here today. At some point in the future we might use more tile scrolling effects to create some like rotation, like in some Traveller's Tales games like in Pugsy, but I think that's enough for now. Okay, so that's about it for this video. Thanks very much for watching, and if you like this kind of content, don't forget to subscribe.
I'm interested in this.
And if you'd like to support my work further and get early previews of what I'm up to, then I have a Patreon account and any support is much appreciated.
You won't go unrewarded.
Until next time,
farewell.